Thank you, and good morning. I didn't know we were going to have a resume rundown, but thanks for that nice introduction. So as you just heard, I'm not a technologist. I can't tell you about code and how computer systems run. I'm an economist, and so I focus more on how people utilize technology systems. So as was mentioned, I'm a founder of Prysm Group. We spend time helping projects, whether those are in the private sector or in the public sector, think about their design and how they can accomplish the goals that they're trying to accomplish. So I really appreciated one of the comments from the last speaker about designing the good future. I think I'm paraphrasing slightly incorrectly, but that's the type of thing that we think about. So one thing that I would really like to highlight as we're thinking about how technology can help improve society, I'll come back to this slide. If we're thinking about how technology can help improve society, we want to think not just about what a technology is capable of doing, but we also want to think about what people are going to choose to use that technology for. So economics can help us with this because economics is the study of choice. So we want to understand how people are going to interact with and how people are going to choose to use these technologies. Now, when it comes to distributed ledger technology or blockchain, there's one feature that I would really highlight. And again, since I'm not a technologist, I'm not going to go into the details about how blockchain or DTL works. But what I want to emphasize here is that these technologies are they're basically shared databases. So they can do mostly exactly what other types of shared databases can do. The key difference for blockchain and distributed ledger technology is that these are databases that have no central administrator, which might sound kind of odd to a group of folks who work in government, but this can actually give us an advantage when thinking about how individuals and entities choose to adopt or choose to utilize the technology. So I'm going to go on what seems like maybe a little bit of a tangent, and I'm not going to talk about technology at all. I'm going to talk about economics, a key concept from economics, just for a few minutes. So this concept is called the hold-up problem. Imagine that there is a group that wants to set up a power plant, and they're trying to figure out where they should build their power plant. And since this is kind of an old example from economics, this is going to be a coal plant. We'll talk about renewable energy a little bit later. In any event, there are several coal mines where this entity can choose to locate its plant. And you would have an advantage if you can locate the plant right next to a coal mine, because you're going to basically make the cost of transportation zero. So this is the ideal situation. We have a coal plant, we have a mine right next to it. The coal goes directly from the mine into the plant. We produce electricity. This is wonderful. Now, there's a big problem here. And the problem is that once you build that plant next to the coal mine, it becomes way more costly to get the coal from any of the other mines around. And so the owner of the coal mine can say, hey, to the plant owner, hey, it's becoming more and more difficult for us to get this coal out of the mine. I think that you should start to pay me more for that coal. And this is exactly what the holdup problem is. So once you've made this relationship-specific investment, you can get held up by that partner. And the result of the holdup problem is not actually that the plant owner is going to be paying a whole lot extra money for their coal. The result is actually that in the first place, they decide not to build the plant next to the mine. Instead, they build it somewhere where it can be sort of equidistant from a few different mines that keeps their options open. But obviously, this results in overall higher costs than if they were able to locate directly next to one of the mines, right? So this is what we call suboptimal investment. Now, what does any of this have to do with technology? What does this have to do with blockchain? This problem, this holdup problem, applies directly to shared databases. So if you think about an example in the healthcare sector in the United States, we have lots and lots of different types of entities who all have to work together. Since we don't have government-provided healthcare, you'll have the insurance company, you'll have the healthcare provider, you may have other providers, labs, et cetera, who all sort of need to work together on a common set of data. Who's insured, what are they covered for, et cetera, and so forth. So this particular system could really benefit if we could all bring our data together. But what would that require? That would require that we're all using the same software system, that we put our data in a place where we can all access the right information that we need. It would require that we all format into a compatible data structure. That's a lot of work. And actually, any one hospital that might be thinking about switching from one kind of electronic medical records provider to another one knows that not only do you have to figure out how to transfer your data from one software to another, you also have to retrain all of your employees to use the new software, right? So there are major investments that go into adopting a new database, and particularly major investments that go into adopting a shared database like this. And so once you're in, your outside options, that other coal mine where you might be able to get coal from, look a lot less attractive, and that can subject you to holdup. So what happens in the case of shared databases often is because of holdup, we don't adopt them. Instead, we keep our data siloed. You have your data, I have my data, they don't really speak to each other, and we're not able to gain the advantage of being able to share and communicate about this data. So how can blockchain help with this? So this is a summary of how the holdup problem works. You have a consortium you would like to set up. The contributors are going to have to make a big investment in order to join that data consortium. But we have these problems with holdup, contracts are incomplete, you're going to have renegotiations, and the investments are going to result in reduced leverage. And so we never end up forming our consortium. So blockchain. We have a few key traits of blockchain that can help us with this holdup problem. I'm going to start with the one in the middle, coordination. So again, when we're thinking about using a shared database, it's because we all want to get together and we want to be able to utilize our data in a new way, right? And we want to be able to understand patterns across different entities and to be able to match up our previously siloed databases. So blockchain helps with that by being a shared database. On the far right-hand side, we have commitment. So another thing that blockchain and distributed ledger technology can help with is by automating certain processes over the data. So you may have heard of smart contracts. Basically what this allows you to do is take an activity that previously would have required intervention, right? We have an agreement that if a certain service provided, the service provider is going to get paid. Now we can automate that when the service is provided, the payment is automatically released. So that helps with commitment. And the final piece, which is the most important piece for holdup, is control. So this is basically saying that when I get into the shared database to the data consortium, I'm maintaining my outside options in a way that doesn't subject me to holdup. So because we don't have one central administrator, we don't have that one entity that could possibly apply pressure, instead we have that all the participants have equal rights, particularly to the data that they themselves have contributed. So I run one of the nodes in the database, so I have a full copy of all of the data. Now, some of that might be encrypted in a way that I can't read it, but I can read what I contributed. So if I want to come out of the consortium, I can take all of that data back with me fairly easily. Okay, so I'm going to talk about a few examples from where public and private can work together using this kind of setup. So my favorite example here, and because I think it reflects back to our example that demonstrates holdup, is in power utilities. So there is a project running out of Brooklyn. It's called the Brooklyn Microgrid, and it allows local individual families and businesses to set up solar panels on their properties, and then they can buy and sell the energy within that microgrid between the different participants. And the blockchain helps keep track of who is contributing how much power and how much power are they buying out of the system, right? And so using a distributed ledger for this reduces that centralized power. So you can imagine that there might be a significant difference in willingness to invest in this type of project or this type of renewable energy if when I, as a business owner who has solar panels, if I need to sell to a central utility, I might be more reluctant to actually set up those solar panels because I might be concerned that they're not going to give me a fair price when I want to sell my solar energy to them. So using the distributed ledger technology allows us to create a more distributed marketplace that can then lead to better investment in these kinds of technologies. But there are a variety of examples where blockchain is being used in public-private partnerships, public health for monitoring population and outbreaks, supply chain management for monitoring the possibility of counterfeit goods getting into the supply chain, pharmaceutical research. There are many, many, many examples where these are being used, where in the private sector, you have entities who would benefit from the use of a shared database, but they haven't been able to get that off the ground. They haven't been able to do that yet. And in these examples that I'm showing you, the public sector has a vested interest in seeing that those solutions eventually do get developed, right? We want to move from the current state where things are not so good. We don't have as much renewable energy as we want. We have too many counterfeit goods. We don't have the development of pharmaceuticals that we'd like to see, things like this. And the involvement of the public sector can help get these solutions off the ground. So far, I may have made blockchain sound like this magic cure. And I want to be very clear, it is not, right? So blockchain is one piece of a suite of solutions that have to work together in order to see these potential great gains. And other pieces of this that are really important are things like developing data standards, right? So in order to get to a shared database, as I said before, you need to have that everyone is using the same data formatting, the same standards, that we all recognize that when we set the month, we're going to use a number for that, right? And these things seem really, like little minutia, but they can be incredible impediments to bringing folks together to eventually operate a shared database. So the formulation of standards is going to be incredibly important. Another really important piece of this is understanding who is going to own the software that we're using to manage this shared database, right? And so even if you have that database, you have the data itself stored in multiple places. I own a copy, you own a copy. That doesn't completely solve this control issue, right? So have you ever written a document in using some form of software and then had to transfer it to a different computer and realized that you weren't able to open it again because you didn't have the right software to open it. That can be a problem. So it's not just about data custody, it's about being able to read the data that you have in your custody. And so we need to come up with new ways to manage the property rights over software so that these folks who are participating in the shared database can have access even if they decided that they no longer want to participate in the shared portion of that. That is what helps reduce the holdup. And finally, governance. And here I don't mean government, I mean how are we going to manage the progression of this project over time? How are we going to make big decisions about how things will unfold in the future? And who are we going to involve in those decisions? And who are we going to give a say in what happens and how the investment goes going forward? And I think all three of these key pieces that are you need to add them to the technology you're using, to blockchain or distributed ledger, are places where government or the public sector can have an important role. So we've seen historically that oftentimes a fragmented private sector can be very, very bad at developing standards. Each entity has its own preference for what the standard will look like, and they can just fight for years and years and years and never get to a solution. So the public sector stepping in and mediating that conversation, not necessarily dictating what the standard should be, but helping come to some agreement can help get these solutions off the ground faster. And likewise, with property rights, we need to maybe think of a greater spectrum of what property looks like, other than we have private IP or we have open source. Maybe there needs to be some options in between that, and it's up to policymakers to determine what kinds of rules we want to have regarding intellectual property. So I have 5 imperatives for public-private blockchain initiatives. And in particular, I think for these 5, there's a big role for the public sector in pushing these kinds of projects forward. So you all in this room may now have in mind a particular case or situation where it would be nice to get all these different entities together to have a shared database, but we haven't been able to do it in the past. And why have we not been able to do it in the past? Because people don't want to join. They're afraid that once they do join, they're not going to like the outcomes and it's going to be really difficult to back out. So if you can identify those situations, then you've picked some targets that might be prime for using a technology like distributed ledger or blockchain. So next is thinking about how to use this technology through an economic lens, right? So again, with distributed ledger technology, the main key here is that we don't have a central administrator. The database itself can do anything that a centralized database can do. The big difference here is how are people going to choose to use it, right? And what does it mean to us that we don't have a central administrator? What kinds of adoption and participation can we get because we don't have a central administrator? Then we want to think about facilitating the development of the standards that will be required for the particular use case that we're thinking about implementing. And here again, there's a big role for the public sector. 4 is addressing the software issue, not just the data itself. And as I said, the public sector has a big role to play there. And finally, creating collaborative governance rules so that these systems can be maintained over time. So it was a really brief talk today. We've written a white paper that discusses at length holdup and situations where holdup is likely to arise, and how blockchain can help, but also the limits of applying blockchain in these contexts. So if you're interested in that, it's on our website. And feel free to come chat with me after the talk. Thank you all, and have a fantastic day.